Hello out there and welcome to the session of the world of electrification and automation. I am Michaela Mönikes and my next speaker here in the studio is my dear colleague Bernd Schüpferling. And Bernd will present digital switchgear for intelligent secondary distribution grid automation. And please post your questions during his presentation at any time so we can answer them live at the end of the presentation in our Q&A session. I'll be your voice, read your question, and Bernd needs to answer them. Please do make intensive use of this possibility to directly address our expert. We are here just for you. And one question is exposed to us rather often, and so I'll answer it directly. We do record the session, and you will get access to the session. Bernd, I know you would like to focus on intelligent secondary distribution grid automation, and our auditorium is curious to learn about the smart RMUs of the ADJH family. Bernd, the stage is yours.
Thank you very much, Michaela, for this introduction, and good morning, good afternoon, everyone out there. It's a pleasure for me to have the opportunity to present you with this conference the topic Digital Switchgears for Intelligent Secondary Distribution Grid Automation. Within this presentation, I would like to give you an overview about our eco-efficient and intelligent ring main units, the so-called IRMUs, as well as on low-power instrument transformers as an alternative for conventional ones, and about the distribution automation devices installed in the IRMU or the intelligent substation. Let's first have a look on the eco-efficient and intelligent ring main units from our 8DJH family. The 3 Ds, digitalization, decarbonization, and decentralization, have also influenced the requirements on the design of gas-isolated ring main units, which have used SF6 as insulation gas for the last 35 to 40 years. Decarbonization has pushed us to develop an alternative concept to prevent the use of SF6 in the future. Digitalization has brought us to implement further IEDs and sensors in the RMUs. Decentralization is last but not least the driver for more and more distribution grid automation functions to master the challenges of the influence of e-car charging and renewable energy supplies on the distribution grids. The result of all these requirements are our new eco-efficient and intelligent ring main units 8DJH12 Blue GIS and 8DJH24 Blue GIS. Equipped with low-power instrument transformers, distribution automation devices, IoT connectivity, and different sensor technologies and apps for condition monitoring and distribution grid automation. Blue GIS is our solution for reliable, sustainable, and efficient gas-isolated switchgears without any F-gases or chemical additives, which do not cause any CO2 emission costs during the whole lifetime. Blue GIS is your future-proof investment with a high performance and a long service life. Next to the SF6 version, we have in the meanwhile 2 new Blue GIS members in our 8DJH RMU family. The 8DJH12 Blue GIS up to 12 kV with 20 kA rated short-time withstand current and 630 amp busbar and feeder currents, as well as our 8DJH24 Blue GRS up to 24 kV with 20 kA rated short-time withstand current and 630 amp busbar and feeder currents. Both provide 3-position load break switches and circuit breakers in different feeder types with a well-proven Siemens vacuum interrupters as individual panels as well as in block-type designs. When we think about the question, what makes the new Blue GRS as well as the classical SF6 RMUs intelligent, we need to consider the following components. An intelligent gateway or RTU, for example our CCAM A8000 family, a communication modem, a UPS with a power supply unit and a battery, a motor control unit, an intelligent short circuit earth fault indicator, here as an example our CCAM FCM feeder condition monitor with external or integrated low power VTs and last but not least low power CTs. For about the last 10 years, low power instrument transformers have become more and more popular in ring main units to provide current and voltage information with high accuracy class from the medium voltage distribution grid to be able to monitor the load flow and the direction of possible faults. The current sensors for our 8DJH family are based on a low power inductive current transformer where the current is converted into a proportional voltage by implementing a precision shunt. They provide an output signal of 225 millivolt at nominal current, which is in our case 300 amps, with an accuracy class up to 0.5. They are available in different housings as split core and closed core types, as well as a combined housing, especially for the 8DJH ring main feeder, where we are also able to integrate the sensitive earth fault current core. Voltage sensors are available as pluggable resistive dividers in different shapes, dependent on the type of cable T-plug which is in use. As the backside cone of non-symmetric cable T-plug types are not standardized, we have in the meanwhile several different sensor types in use. All of them provide an output signal of 3.25 volt at square 3 at the nominal voltage with an accuracy class up to 0.5. For further temperature monitoring, they are optionally available with an integrated PD100 temperature sensor. As current and voltage sensors as separate components required further site installation efforts, and as the voltage sensors are dependent on the type of T-plug, which is each and every time a logistic challenge, to have the right plug for the right sensor on site, we had the idea to integrate the sensors in the cable connection bushing as part of the intelligent RMU. This solution, the so-called SI bushing, Smart and Intelligent Bushing, will be launched within summer this year. Together with a special version of the CCAM FCM short circuit and earth fault indicator, we will be able to provide an optimized integrated solution in our RMUs. The SI bushing is designed with a Rogowski coil for current measurement and a capacitive divider for voltage measurement. Both sensors are compliant with the instrument transformer standard for passive non-conventional voltage and current transformers. The Rogowski coil provides 22.5 millivolt at 50 amp 50 Hertz, and the capacitive divider has a transmission ratio of 10,000 to 1. Both provide an accuracy class better than 0.5. An integrated PD100 is used for ensuring the accuracy of the voltage measurement over a wide temperature range, as well as for further temperature monitoring of the cable connection. For the connection of a VDIS system to determine the absence of the voltage, we have implemented a second capacitive voltage divider separate from the measuring one. To be able to transfer the sensor informations to the control center or into the cloud for further applications, we need further distribution automation devices like FPIs and RTUs. The Siemens Intelligent Short Circuit Earth Fault Indicator is called SICAM FCM. It measures voltage, current, and can calculate all kinds of powers, cosinus phi, and the frequency. It is designed for rough ambient conditions in secondary transformer substations and provides inputs for either non-conventional as well as optionally for conventional CTs and VTs. It provides a wide range power supply as well as a Modbus communication interface and an event archive. The SICAM A8000 is a Siemens RTU platform for the integration in intelligent RMUs or substations. Various modules for analog and digital inputs and outputs, as well as a robust design for harsh environment conditions, together with integrated security and communication functions, makes it to the perfect RTU for secondary distribution automation functionalities. If space limitations do not allow to install the RTU in additional low voltage compartments of the RMU, we can also provide an external so-called distribution automation box to be connected via a standardized interface to the RMU and installed in another area of the substation. To summarize the content of my presentation, I would like to highlight our consistent concept for the secondary distribution grid automation within the intelligent transformer substation. All components on the medium and low voltage side can communicate via a standardized Modbus RTU communication interface to a central remote control unit, which provides further communication to the control center and/or in the cloud for further applications and transparency of the secondary distribution substation. Happy customers all over the world are already using our solution of intelligent ring main units for further distribution grid automation functions to master the challenges of the influence of e-car charging and renewable energy supplies on the distribution grid. If you are looking for a competent partner for digital switchgear for intelligent secondary distribution automation, we, as Siemens, can support you in the project planning as well as during the realization phase without our experience from worldwide executed projects with components from our perfectly tailored portfolio. Thank you very much for your attention, and don't hesitate to contact me for further questions or ask them now, as in my opinion, we have enough time to answer them immediately.
Thank you, Bernd. Yes, we do have time It was a crisp presentation, so we definitely have time for questions. And I invite you again to ask your questions directly to Bernd. I have some there, but we have more time than I have questions right now. So think about what you want to know from our expert. We are here for you. The first question I see here is, does SECAM FCM good for 400 Hertz? And what voltage and current sensors works on 400 Hertz, please?
I would say 400 Hertz is not the usual frequency we have in the distribution grids. So therefore, the SECAM FCM is designed, first of all, for 50 or 60 Hertz applications, and up to 40 kV, 40.5 kV for the standard medium voltage grid applications. To be honest, I'm not able to answer this question. I have to take it with me. The 400 Hertz is, I never heard this question, but we will check it and we will come back with an answer after this session.
Perfect. Thank you. And then there is the question, are there any examples of algorithms implemented on medium voltage or low voltage substation level?
Also a question which is very specific. So I interpret this question as if we have further, let's say, applications to manage the grid automation, the secondary distribution automation of the grids. And yes, we have further concepts. I think we have also today, or was it already, a special session from Oliver Schrödel, who is our expert for these applications. And in my opinion, he has a lot of these applications already implemented in all our devices. And Oliver can help out of this situation, can give you the right answer for these questions. And if not, then it's the same. Please ask the questions and I will get the information and will provide it after this session.
And I have another idea for questions like this. If you feel that the answer is not what you expected, or if we eventually misunderstood your question, join the exhibition, check the Meet the Experts Teams button there. You see it's circled right here, and then you are directly connected and have the possibility of a one-on-one meeting with one of our experts. Bernd is not yet there, but his colleagues are. So take the time, stroll through the exhibition and just meet the experts there. We are here for you, not only here in the studio, but also inside the exhibition. Might be a little bit hidden, but make use of the possibility. Then we go back to the question and answer round, and now questions are really coming in. Thank you for that. So do you offer complete digital substation, including a substation housing?
Yeah, this is a very good question. So to be honest, most of the substation buildings, or especially the compact substations, we are relying on partners. So because we are not the experts for concrete cement substations, so therefore we have partners for that. We have our own concept for metal clad substations, where we are also offering and providing a partnership concept. So that means, dependent on the market in which country the request comes up for complete substations, we have either partner or we can provide a partnering concept for our own concept of a metal clad substation.
Okay, thank you. And then there is the question, when SI bushing will be launched tentatively?
Yeah, so the answer in the presentation was around summer. Around summer means at the moment it's planned for end of July, beginning of August. To be honest, we have it already offered, provided, and already also delivered for pilot applications. So I'm not talking about something which is not reality at the moment. So it's already there. We are in the last phases for our configuration, for our tests. But we are pretty sure that the Z-bushing will be available in August latest. And then also, what is the most important thing, Z-bushing alone without any device does not work. So we need also the IEDs to be connected to the SI bushing. And these already also will be, or we have already some available, and the others will come around summertime also. So it's very good aligned that we will have the IED and the I bushing at the same time available.
So we talk about summertime, European summertime for the total release, kind of, and the Southern Hemisphere summertime for the pilot customers right now, kind of. Okay, thank you. So up to what temperature outside can this work, as RMUs are expected to be installed outside?
Yeah, so I think it was mentioned on one of the presentation slides. So the IEDs, especially, which are the most critical thing, are designed for -40 up to +70 degrees. We know that the real occurring temperatures, especially when you have applications in Saudi Arabia, where the whole day sun is shining on top of a metal roof of the substation, then we also have there 80 or even 90 degrees. And yeah, as I said, from the standard, they are tested up to +70 degrees, but these applications we have already since years in use. They withstand these harsh environment conditions, and we are sure that also 80 or 85 degrees is not a big topic if it's not permanent, and I expect it's not, because after a day, mostly it comes night, and then you will have a cooling down, and therefore, yeah, these +70 is a tested IEC standardized temperature, but we can withstand also a little bit more.
That's hot. I don't want to work there, so I'm glad that only the sensors are there. Is voltage sensor and current sensor use merging unit technology for the communication with protocol protection devices or RTU?
Yeah, so we have two different applications for that. So the voltage and the current sensors I have shown and presented. In this application, they were connected directly either to the short circuit loss fault indicator or directly to the RTU. But we have also in our portfolio so-called standalone merging units or a merging unit integrated in a protection device. And for these applications, there will be special interfaces also in the future. So today I have shown that what will come in summertime. A little bit later, there will come up more. So we are also talking about special protection relays to be connected to the SI bushing. And in these protection relays, there will be also in the future a so-called merging unit functionality that we are able to transmit the analog signals to the so-called process bus communication to be integrated or to be an integrated part in complete digital substations, also for primary digital substations.
Okay, thank you. So once again, it makes sense to just stay tuned to all our channels because things are coming through the year. Is CCAM capable of handling decentralized self-healing grid? Is the question.
Yeah, this is something coming back to, I think it was the first question, one of the applications for this whole concept. And I'm pretty sure that Oliver later on will present some of these applications. Yes, it is. We have already the so-called self-healing grid applications available, programmized, configured in these RTUs. So again, if there are specific questions for these applications, maybe also with special requirements, we can manage them. We have already a lot of experience for these self-healing grid applications, but we are also very flexible to manage also the specific customer requirements.
And I think this presentation that was yesterday already with with the large fish farm in Norway. Right. And I think it is already available as a recording. So if you want to dive deeper into the topic of the CCAM applications, of this use cases there, scroll through the agenda of yesterday. We had Oliver with the self-healing grid application. We had, I think the next session was about all the CCAM applications we have with the CCAM 8000, and then we had the CCAM microgrid applications in a row in yesterday's agenda. So it might be interesting to take a look at the recordings there. We stay in this course.
Yeah.
We take one last question, and this is, can we achieve class 02 accuracy with current and voltage measurement sensors?
Yeah, also a very, very good question. As I mentioned in the presentation, our, at the moment, planned accuracy class to achieve is 0.5. But we know that for further applications like metering, like billing metering, the 0.2 is requested. So at the moment we have designed, tested the 0.5, but we are even a little bit more better than the 0.5. So there's some, I would say, room for improvement that we can achieve also the 0.2. We are working on that. But the one topic is to have the 0.2 accuracy in the sensors, but on the other hand side, we need also the country-specific regulators to have already the regulations to use the application also for billing metering, for example, because these regulations are not yet established. We are already in contact also with some manufacturers for billing meters. We have own power meters in our portfolio. So all of them, we are in contact to have a solution in the future, maybe also for the 0.2. I could not promise it 100% at the moment. As I told you, we have to evaluate the accuracy of these sensors, which have at the moment the capability for 0.5. But we are pretty sure then we can have or make it a little bit more better in the future.
Kind of, we are on track there.
Yeah.
Okay, thank you. I see still questions open in the line. That's no problem. We cannot take them now online here, but you will receive an answer via mail, no problem, or visit the exhibition and ask your question there again, no problem. You can also have questions later and then contact. I think, Bernd, you are on LinkedIn, for example.
Yeah.
That's one of the contact possibilities. Then we have our web pages with contact functionality there. Bring your questions to us. We will get back to you. And as I already mentioned, we recorded this session as we recorded the other ones, and the recording will be available to you. Now, thanks a lot, Bernd, for this interesting sessions. Thank you for your time and presenting this digital switchgear for intelligent secondary distribution grid operation. And in about 15 minutes, your agenda tells you that our next conference speaker will be Bruno. There is a little change in the agenda. We will have Oliver Schrödel with us, who will jump in for Bruno, and Oliver will present information on how to master distribution grid diversification by IoT. Thank you for your time. Thank you for staying with us. Thank you for the presentation and for answers. And so I just say goodbye for now.
Goodbye.